Mounting antennas was always a challenge for me because I have very limited space at home. Even the 40-meter inverted V, I found it very difficult to mount, and I got a good position only after several attempts at different configurations. So 80 meters almost unthinkable. That's when I heard of VU2XTO design of upgrading a 20-meter antenna to 80 meter using two loading coils and an extra length of 2-meter wire on either side. That sounded very exciting for me because that is shorter than a 40-meter dipole. So I will certainly be able to mount that inverted V antenna for 80 meter with loading coils. Let us see. What we need is a couple of 118 microhenry loading coils and about 14 meter of insulated copper wire. For the 118 microhenry coils, VU2XTO has suggested a 15 centimeter UPVC former of 1.5 inch diameter and 18 SWG enamel copper wire wound closely for a span of 11 centimeter. It is basically an upgrade of a 20 meter antenna. So you need two pieces of insulated copper wire of 5 meter each from the feed point to the loading coils on either side. Beyond the loading coils, we need another 2 meter each of insulated copper wire to make the antenna tuned for 80 meter also. It has been suggested that we should first tune the 20 meter part of the antenna for 1:1 SWR and then tune the extra 80 meter part. As I was not quite sure of how much enamel copper wire I would need, I went out and bought 500 gram of 18 SWG enamel copper wire along with 15 meter of 2.5 square millimeter insulated copper wire, of which I'll need 14 meter for the antenna. Remaining part may be kept as extra for tuning and tying the antenna, meant to be kept folded on either side. The 15 meter copper wire was cut into two equal halves so that each half would be 7.5 meter. Then 2.25 meter pieces were cut off from each half so that 5.25 meter would remain. Coil all the four pieces separately so that they would not get tangled together. Checked the PVC pipes available here and found this one would match the VU2XTO design of 1.5 inches. Marked out the required 15 cm portion using a scale and knife. Then two 15 cm pieces of PVC pipes were cut using a hacksaw. Two positions were marked on the PVC pipe pieces 11 cm apart for drilling holes. Two sizes of drill bits were used to drill holes, one each for the 18 SWG enamel copper wire and the 2.5 square millimeter insulated copper wire for antenna elements. Here you can see the enamel copper wire and insulated copper wire pass through the new drill holes to make sure that they were of sufficient diameter. Pliers were used to keep the pipe pieces steady while drilling. A small pit was made on the PVC pipes using the sharp edge of a screwdriver before using the electrically operated hand drill to avoid the drill bit slipping off from the PVC pipe. This was the first loading coil which I made. It took about 20 minutes for me to wind it. As I do not have an inductance meter, I can only check the performance after mounting the antenna in full and testing SWR as well as on-band performance. Second loading coil which I made is here, along with the left out portion from the 500 gram enamel copper wire which I had bought. This time I could make the coil in about 15 minutes. Now I have to join the coils and the wires as per design and mount it on the mast. After that will come the laborious process of checking SWR and tuning the antenna for lowest possible SWR.